Yeah, just make sure that it kind of captures everything. Yeah. So I'm updating them. I'll be updating them over the course of the semester. But most of the time we'll spend our time in Visual Studio or drawing stuff on the whiteboard and figuring out problems, geometry problems, right? So, but today is going to be PowerPoint, just because I want to give you guys the background to the course and explain what the course is all about, and basically set the expectation from my side and set the expectation from your side, so that you understand what you're getting yourself into if you decide to take this module, right? And I know you've maybe put it down in your form, but you don't have to take it, okay? So, I'll tell you what is Game Engines, what Game Engines is not, what are the prerequisites, what exactly will we do, what resources do we need, what is the assignment. I'm going to spend a good bit of time talking about the assignment, because the assignment gives you a good sense for the type of stuff you're going to be working on every week on the course. And then, what do I have to do to pass? I think I got rid of that slide, because I don't even want to answer that question. If you're just here to pass fourth year, then this probably isn't the subject for you, right? I mean, I'm looking for people on this module who have a bit of passion. Number one most important thing, who are interested in figuring out really at a deep level how computer games work and how 3D graphics work and how this amazing thing called the Oculus Rift works. I mean, this has really just so invigorated me in terms of how I think about programming and computer science and everything. I'm absolutely blown away by it. So I want people who are kind of on my wavelength, like who are equally excited about things. I don't want people who just want to get a bare pass or scrape through. You know, I'm interested in people with a bit of passion. Okay. So what is Game Engines 1? It's a foundation course in programming, maths and physics required to program 3D games. Okay? Consider the following games. Can anyone tell me what that one is? It's written in the corner anyway. How many people have played it? A great game, Alan Wake, right? So a really cool game. I just picked a few games that I like. What's that one called? Journey. How many people have played it? A really awesome game. I'm in the process of playing it. It's a real discovery, actually. It's a wonderful game. Lots of lovely flying experiences, and it's real trippy when you play it. It's lovely. What about that one? How many people have played this? I should really say how many people haven't played it. If you haven't played it, okay, alright. So somebody hasn't played it, it's no problem. What about that one? I guess everyone's probably played that at some stage. Team Fortress. What do they all have in common? They're all programmed in C++. With a scripting engine. Some of them use Lua, some of them use other scripting engines like Unreal Script and that, but they're all programmed in C++. They're all 3D rendering of textured objects. So they all have a scene graph. They all use particle effects. They all have realistic physics, so ragdolls, collisions, explosions, etc. They all have character animation. That's one thing we're not going to do, but I want to talk a little bit about character animation when we come to the assignment, because that's an option for the assignment. They all have character AI, so they all use behavior trees and finite state machines to control the AI of NPCs. And this is the stuff we're going to do in Game Engines 1. Alright, so we do the foundational stuff required to program any 3D game in any engine from, you know, the first principles. So that you can take the skills you learn on this course, you can go off and learn Unreal, you can go off and learn Unity, whatever technology you need. So it's really about the fundamental skills. What Game Engines is not. Okay, so number one, it's not a C# or a C++ or a plug-in another language course there. I just have a prerequisite that everybody knows OO programming. So we will spend the first week, and the first lab is going to be basically just C++. You know, on Friday, and next week's lab, and maybe the week after that, we'll just do all the fundamental stuff in C++ that you need in order to be successful on this course. We'll have a revision bit. But if you're really struggling, if you really struggled and you got to fourth year by scraping through programming, and by, you know, you're still struggling with the for loop and things like that, then this mightn't be the right subject for you, because there'll be a lot of coding in C++ in it. So that's just what I need to say and get that out of the way. So is that clear to everybody? Is everybody okay with that idea? If you're really great at COD, okay, and you've just bought GTA 5 and you're really excited to spend the semester playing GTA 5, then again, I think it's probably not the right subject for you, because it does involve a lot of coding in C++. Alright? Having said that, C++ is just a given. It's a given that you can program in some OO language, C++, Java, whatever. If you can do a bit of coding, you'll be fine. You'll learn everything else. And you know, I want to bring everybody along on this wonderful journey. I think programming computer game engines is just so wonderfully creative and enjoyable. I spent my weekend, I don't know if you saw or heard, I did a Gamecraft, 24-hour games programming jam up in Derry. I worked with an artist for 24 hours, and we put a game together, which I'll show you today, using the Oculus Rift and Kinect skeletal tracking and everything. And for me, it was life-changing. I just can't describe how how much fun it was to sit around people who are kind of on my wavelength. You could talk code with them, you could talk games. It was wonderful. I want to bring people on this wonderful journey of learning games programming with me. So long as you have a bit of passion and you can do a bit of coding, you'll be fine. But if you're struggling with the fundamentals, then you shouldn't really be in fourth year, and you're going to find every fourth year option subject tough, but particularly maybe this one, okay? Also, we don't use XNA. Up until this course has had 3 iterations. Iteration number 1 was DirectX fixed function pipeline, C++, and a physics engine called the Open Dynamics engine. And that was back in 2006. We did that for a few years. XNA came along, the whole thing moved to XNA and C# for a few years up until last year. XNA, as you know, is like a sick dog. It's been brought out to the lake, shotgun through the eyes. It's dead. So no XNA this year, right? So instead of that, I've rewritten the whole course to use a whole suite of new technologies, which I'll talk about in a little while. So it's not XNA, it's not monogame, it's not Unity, it's not Unreal, it's not even an OpenGL or a DirectX course. It's about the fundamental principles that you can go and learn any game engine or any suite of, 3D graphics library or whatever. It's about the principles and it's about transferable skills. Alright, so once you learn the stuff that you need to learn about vectors and matrices and quaternions and stuff, you can do anything and you can program any engine in them. Okay? Also, for people who are mad into game art, brilliant at 3D modeling and stuff like that, you won't learn any of that on this course. There's no Blender, no Maya, no 3D Studio Max, no Photoshop. It's all about the code and the algorithms. And dare I say it, it's about the maths. Right, I've said it. The prerequisites, fundamentals of OO programming, but we'll go through all of that stuff again. No fear of code. If you're afraid to program, that's not good. You shouldn't be doing this course anyway, but if you're really afraid of programming, if you sit down and you look at, a simple thing like, I did one with your OO programming class where you had to write, I love DIT, and it was 2 for loops. Okay, if you're afraid of those type of programming problems, if they terrify you, again, not good, right? And no fear of maths. So I didn't do honours maths for the Leaving Cert. I've discovered games is it's like the gateway drug for maths. Now I love maths, right? I never saw the point of it. But when you can make things explode, when you can, fire projectiles and they hit or they don't hit in particular ways, it really brings maths to life, okay? And the type of maths you're doing here is not even real maths. I mean, real maths is calculus. Well, you can do a bit of calculus in games, but real maths is hard. This is like game maths. This is geometry, right? Better if you did art for the Leaving Cert, right? That's a good sort of guide as to the type of maths that we're going to do. If you can visualize things in 3D, if you can close your eyes and imagine there's a thing here, there's a thing over here, there's an angle that I need to calculate that way, and I need to move in a certain number of steps. That's the type of maths that this course is all about, right? You shouldn't be in fourth year if you have any of the 2 above. Simple as that. All the subjects in fourth year you'll find hard, but I'm just telling you up front, there's got to be programming and maths. Big style, right? Things that are really good. Passion for technology. So if you're passionate, but maybe you don't have to be the best programmer. It's not about being the best programmer in the world. 10 times, passion will win out in everything in life. Most importantly, job interviews, etc. If you're passionate about what you're doing, then that's way more important than being a brilliant programmer. Right? I couldn't just, that's so important, right? Passion for games. You don't have to have played every game under the sun, but for example, I always ask a question, and it'll come up in this year's exam, so you can consider this a hint, right? There'll be a question on how to program a gravity gun. How many people don't know what a gravity gun is? Okay, so every 3D game has it, and somebody even answered it and saying, I've never played a game with a gravity gun, so therefore I don't know. Come on, that's fundamental, You should know what a gravity gun is. It's a thing that you just look over something with your mouse and you can pick it up when it comes towards you. That's what a gravity gun is, right? In short, any of the following are bad, any of the following are good, and will enable you to be successful in this course. If you are number 1, fear. So fear of programming, fear of maths, fear of computers in general. If you kind of fall at the first hurdle when things get hard, and you go off and spend your lab time playing with Facebook or doing whatever, then that's obviously bad, right? Don't want that. Wanting to just pass, okay, also bad. If you ask the question like, how do I get a first? Then that means you're here to get a first. You're not here to learn how to do really cool and awesome things to create the next generation of Oculus Rift experiences, you know, not good. Good things, passion. So if you're passionate, if you've got a bit of fire, and if you're interested, really curious about how this stuff works, and in my opinion, it's the, I'm going to talk about this in a minute. This stuff that you're going to learn on this course, you might as well, in my opinion, this is why I brought the hat. Look at the hat, everybody. I bought the hat over the summer, especially to wear it today, and I'm going to wear it in a little while, so get prepared. This is fucking magic. This is actually magic. This is actually magic you're going to learn on this course. You are going to learn how to levitate things. You are going to learn how to make things appear that aren't actually there. You are going to learn how to create life forms from nothing. That's what games programming is all about. So if that doesn't fire your passion, then this is not the right subject for you. But if that's the kind of thing that makes you excited and keeps you awake at night, then definitely do this course. All right, curiosity. Again, I now can never look at a computer game again, having taught this course so many times. I'm always wondering, how did they do that? You know, how does that thing work? I want to do that thing. How would I program that particular effect, you know? And then the love of making things. So, number one, most importantly, what's programming? Programming is, what's it all about? A set of instructions to make the machine do what you want. Is it? If you think about programming in those terms, that's not the way I think about programming. I think about programming as two words. Programming is making things. If you like making things, then you know you're going to make loads of stuff. Okay. What exactly will we be doing? So this is in detail, and you know this is exactly. And again, just to not have any expectations that we're going to be, you know, drawing lots of things in Unity, dragging and dropping stuff. We'll be spending almost every lecture in either Visual Studio or drawing diagrams on the whiteboard. Okay. We'll have a refresher on C++, starting with a 2-hour class on Friday. Okay. The fundamental stuff that you need to know about OO programming: objects, classes, inheritance, polymorphism. That's a given, right? You can't do anything on this course unless you get that, and we'll spend Friday and probably next week doing that. Number two thing we need is to understand the STL, Standard Template Library. Lists, vectors, maps, when to use one, when not to use one, what's the right data structure, because I use them all the time on my course. Okay. Number three thing, there's a really cool thing which is in C++ 11 that I make use of a lot in the code that I wrote for this course, and they're called smart pointers. So you're used to, maybe, if you remember, in C, you go malloc and free. In C++, you go new and delete. In C++ 11, you don't have to worry about the deleting bit anymore. You just go make shared, and it uses a thing called reference counting to keep track of how many references to that thing. So it gets deleted automatically for you, like in Java, right, or C#. So we're going to use that because we don't have to think about memory so much anymore. So I'm going to explain how all that works. And then very, very important, compiling and linking with third-party libraries. So you remember, we did Allegro, didn't we? So we're going to link with about 10 different third-party libraries here to make this work. I'll list them all off in a little while. And then also, everything is Git. How many people have used Git before? Okay, so every week, I mean, the stuff I've made is all up in Git. It's all open source, right? You can download everything, just, you know, the whole lot. But every week I'll be making a lab, and I'll be making it a branch of the Git repository. So you'll clone the Git repository, you'll get the source code that you need to work on. One very important thing I'll talk about in a minute is forking and pulling, right? Forking and pull requests. Anybody who does a fork and a pull request, you get an instant first, right? I'll explain what I mean by that. So that's the first thing, okay? A week or two on that. Next thing is maths for games. Coordinate geometry, you know, X and Y coordinates. We'll introduce the Z coordinate. It's very simple stuff, right? Length of a line, calculating angles, you know, Pythagoras. Simple stuff again, right? Next thing, trigonometry, sine, cosine, tangent, inverse sine, inverse cosine, inverse tangent. These are all very fundamental things to games programming. Next of all, we look at vectors. You might remember we did some of this in second year, but we'll bring this along a little bit. We'll look at stuff like the vector dot product, the vector cross product, when you use these. And these are all little tools that are in your toolbox, so that when you decide, yeah, I need to make a thing which turns in a particular way, you'll know how to calculate the angles correctly. And these are just tools in your toolbox. And we spend a long time on this, because everything is kind of based on that. And then matrices. Matrices are used to do stuff like rotations, translations, scalings. And if you want to program OpenGL or DirectX or any 3D framework, you need to know about matrices. OpenGL programming. We'll look at matrices in the rendering pipeline, vertex buffers, vertices, colors, shader programming. So this year we're using the very latest, I decided over the summer, the very latest of everything. So we're using OpenGL 4 or OpenGL 3.3 shaders. So we'll be using shaders and writing some shaders to do lighting, ambient, specular, diffuse lighting to render 3D models. Okay, texturing and lighting, and then we'll do a little model loader, and then we're able to create a scene. All right, so we'll be able to load up 3D objects and render them in 3D. Then we do physics for games. So we'll start looking at the basic 2D physics, so position, time, acceleration, you know, cars traveling at 3 meters per second for 2 seconds, how far has it traveled, all those kind of equations. Drop a coin from the top of the Empire State Building, you know, bullet fires, this is the speed of it. So we'll be able to solve those kind of problems. And then we look at particle systems. So particle systems, you can program particle systems with simple 2D physics. We'd be able to create 2D explosions, 3D explosions actually, just using simple 2D physics. And all kinds of magical effects, like, you know, the kind of magical effects you see coming out of magic wands and stuff. Right. Then we'll look at 3D physics, quaternion rotation sequences, angular acceleration, angular velocity, torque, things like that. And then we'll be able to program a flight simulator. So we'll be able to program the simple physics for a flying 3D object at that stage, okay? Next thing, use of a physics engine. So we kind of jump forward a step. The one thing that we don't do on this course is the collision detection algorithms, because they actually take up entire books. All right, so we're going to use a physics engine, and the one I've chosen to use is the bullet physics engine. So this is the third physics engine that we've used on the course. This one is really nice because it's available for everything. It runs on Android, iOS, everything. It's all written in C++. What's quite cool about Bullet is that it's you actually have to compile it from source. So it's built into your project. You don't get a DLL that you just link against a DLL. You actually have to compile it from source. And occasionally, when my program doesn't work correctly, the Bullet physics engine will throw an exception. And it's really cool. You can jump right into the line of code in Bullet physics and find out where the problem is. It's really very, very insightful, rather than use maybe a closed source one like Havoc, for example. Though if you can program Bullet, you can program Havoc. They're basically the same. So using rigid bodies, joints to constrain things, gravity gun effects, and then we program vehicles. And then the last thing we do on the course is the peripherals. So we look at the Kinect and how to do skeletal tracking using the Kinect, how to program a point cloud, you know, how basically that technology works, and then the Oculus Rift. So we'll program, the last thing we'll do is basically render everything to the Oculus Rift, use the head tracking on the Rift, and we'll be able to make really cool things. So that's the technical sort of stuff that's on the course. What resources do I need? The book that we use is that one. You don't need to buy it, okay? Everything you need will be on the PowerPoint slides that I'm going to make. And also, very important, that you come every week. I would like to think that this is going to be a bit more, you know, of a collaborative learning thing. So I'm hopefully going to learn from you guys, and you guys are going to learn from me over the course of this semester. On Visual Studio 2010, Git for Windows. All the stuff I've developed, if you're on the Mac system, you should be able to compile it all for the Mac, right, using Xcode, apart from the Kinect and the OVR stuff. Probably Windows, but if you're on a Mac and Linux thing, in fact, if somebody's on the Mac, how many people are on the Mac thing here and want to kind of specialize in the Mac, right? There's an assignment for you. Get all my code running on the Mac, and if you do that, you'll get a first in your CA, okay? So this is BGE. This is what I wrote over the summer, and my good friend Scott Baker made me this logo. It's nice, isn't it? So, yeah. You can download BGE. This is what it uses, and these are the third-party libraries that we link with. So it's all OpenGL 3 and 4. Shaders, no fixed function pipeline stuff. It's the latest in every sort of gaming technology that I can find. Glue. GLM is a maths library, so we need a library for doing all the different maths things that we need to do. So we'll use a thing called the GLM maths library. We'll use a thing called SDL, Standard Direct Medial Layer, for creating the OpenGL context and interacting with the mouse and keyboard. All of these libraries will compile on everything from the Mac, Linux, you know, so you can basically clone that repository, and you should be able to, within an hour or two, get it running on whatever system you want, right? STL, TTF for rendering fonts, the Bullet Physics Engine, the Kinect SDK, and OVR. All the dependencies for this project are checked into the repository, so you should be able to just literally clone the repo and build, and it should just work. You don't have to go downloading anything else, apart from the Kinect SDK. That's the only thing which you absolutely need to install. Semester 2, I'm not going to go into huge detail about Semester 2 right now, but Semester 2 is a Game AI course. And so most of the course is steering behaviors. Seek, wander, how to do all the... I think you guys probably saw the demos. Did I show you at the... when we had the little talk? I'll show them to you again as well, but we'll be able to program stuff like flocks of birds and shoals of fish and crowd scenes and stuff like that. So all the kind of steering and stuff like offset pursue and evade behaviors, wandering behaviors, path following behaviors, all those kind of behaviors. About 50% of the second semester course is about that. Then we'll look at finite state machines and behavior trees and pathfinding, navigation graphs, navigation graph generations. That's semester 2, but I'm not going to really talk too much about it now. You can do semester 1, you don't have to do semester 2. There's other options in semester 2. Okay, if you don't want to continue with the course, but I think you should because it's brilliant. So here's your assignment. Oh yeah, I got to wear the hat. Okay, so your assignment, we've done loads of different assignments in previous years. What are you laughing at? We've done loads of different assignments in previous years, okay? Mostly to do with making physics machines. But this year, I'm just so impressed with the technology that we're going to use on the course that this year the theme of the assignment is magic. So you got to make something magical, right? You can use whatever technology you want. You can use the technology you were learning on the course, which is BGE, my little game engine. If you want, you can do it in Unity, or you can do it in Unreal, or whatever you want. You can program it in C#, C++, whatever technology you want, okay? I'm not going to constrain you. Think about using the Kinect, Wiimote, PS Move, Arduino and sensors, the Rift, Leap Motion, particle effects, music, speech recognition, and then I just have a few different things here for you to kind of get inspired. You can do them in teams if you want, or you can do an individual assignment. If you're doing it in teams, the only constraint is you must make a Git repo and keep everything checked into your Git repo and add me as a collaborator, and so I can see who's doing what on the project. That's all. And again, we'll have a crash course in Git next week. So what's that?
Force Unleashed.
It's the Force Unleashed. That's force powers. Okay, so you can do force powers. Who's he? That's Gandalf, right? You know who Gandalf is? Okay. So if you're into the Lord of the Rings, do something Lord of the Rings themed. There he is again. Oh my god. Pyrokinesis. Alright, if you want to create a simulation of pyrokinesis, you can even use the... What's the name of that thought thing that tracks your thoughts? They're very cheap, and they're really cheesy little devices that you concentrate and it tracks your brain waves, you know. So if you want, you can do that and then make some fire appear, you know, over the other side of the room. Harry Potter, if you want to do a Harry Potter type thing, you know, wands with particle effects whizzing out the end, cool. Use a Wiimote. What about him? That's kind of magic, isn't it? Levitation. I can't remember what that is. An alien of some form. Beautiful, gorgeous particle effects going all over the place. I love things like that. There we go. Matrix. You can take that as your theme. You can do something Matrix-like. Once you try on the Rift, by the way, and hopefully, you know, we'll have a few people will be able to have a go of it in the second hour. It really makes you think about, are we actually living in the Matrix? Like, I have this theory now, right, that I'm actually a very old man. Well, I am a very old man anyway. But I'm an old man wearing a very, very advanced Oculus Rift right now, reliving my life, which has been downloaded to a computer. Makes you have those kind of thoughts. Anyway, why not do something Matrix-like, okay? Or this guy, or this. Hands-on healing. All different types of magic, right? Just to give you some inspiration. Different things that you can make. There's Reiki. Another force one. Shields. More hands-on healing. What's that one from? It's Mass Effect. So you can do mass... What do they call them in Mass Effect? Are they just called powers, or are they called... When you get them and you kind of level up and stuff in Mass Effect and you get new ones, what are they called? Are they just called mass powers? I can't remember what they're called.
No, they have some made up science in
Yeah, I think you're right. They do, yeah. And there's just, I don't know, hallucinogenic trip. And again, levitation. So think about trying to create these effects using the technology you're learning on the course. Yeah, what's that one from? That's the Matrix, spoon bending. And there is a magic wand with some cool stuff coming out the end of it. Again, another thing you could consider maybe doing with the Wiimote. Track the Wiimote, use the Oculus Rift, so you look down and you see your hand, but you see actually really cool particle effects coming out the end of it. Can't remember what that one's from. That's another Force Unleashed one, is it? Who's that? That's the Flying Spaghetti Monster. Again, just thinking about magic. And there's, actually I think this is sort of astral projection, sort of related. Yeah, what's that one from? That's the Matrix again, right? This is what we all are. We just don't know it. I'm the only one that knows. Okay. So decide which one you want to take, right? Special quests. I bought the hat over the summer specifically because I knew I was going to have special quests, right? You can do the magic thing if you want. I don't want anyone to feel constrained by the assignment. Sometimes it's good to be constrained. Because when you're constrained, it forces your thoughts to try and be creative. So I think it's good to be constrained. But I don't want you to think that, oh, like somebody even made a point last year, the second semester assignment is usually to recreate space battles from classic sci-fi movies, right? And then somebody said, that was very indulgent of me because, you know, I'm not into classic sci-fi, so why did you make me do this assignment? I don't give a shit, right? You do whatever assignment you want. Just take the technology you're learning on the course and do something cool with it. If you don't like magic, or classic sci-fi, or spaceships, or robots, I don't know what you're doing on a computer science or computing degree, but you don't have to. Do whatever you want, okay? Just fit it in somehow with the course. I don't want you to feel constrained by it, unless you want to be constrained, which is actually a good thing. So I put a few things that I didn't get around to doing over the summer that I think are reasonably significant pieces of work that should take a few days to do. So number one would be to add Lua scripting to the thing I've developed so that you can write scripts and you can spawn objects using Lua scripts. Now if you're more from a computer science perspective and you don't really get turned on by the idea of doing magic, then this is a really good one to do because you're going to use a thing called Lua bind. And you do loads of really nice C++ stuff, okay? So it's more of a techie type of a thing. It's really great if you want to do that. Scene management. So in my engine, everything gets created. When the program gets shut down, everything disappears. Real game engines have scene management. So in other words, you can say, go from this thing to this thing. And you can create like full screen splash screens and menus and stuff. So I don't have any of that stuff. But if you want to make that in a way that's useful and will be useful to the next year's people who are going to take this course, then that's another option. Add support for the Leap. I bought a Leap. The Leap arrived the same day as the Rift. The Leap got installed, played with for all of 5 minutes, and then I haven't hardly taken the Rift off. I'm still wearing it. Or am I? So anyway, so if you want to do something with the Leaps are really cheap as well. I'm sure DIT will buy you one, no problem. Really improve the particle system. So I have a very simple particle system that we will learn how to program. But really, particle effects are done now on the GPU shaders. So if you want to write a shader particle system, that'd be a really cool assignment as well. And now this is for somebody, if there's anybody musicians or are really interested in electronic music and audio and stuff, there's a quest for you. And the quest is, I recorded myself saying bang and bing, boo and stuff, and they're the sound effects that you hear, and they sound awful. They really don't work at all. So if you want to spend some time making realistic audio and also programming Fmod, which is the third-party library that I use for audio to do stuff like occlusion and positional audio and Doppler effects and stuff like that. If you want to get really deep into that, then that's a really cool quest that you can do for your assignment on this course. So any of the old assignment topics are also options for you as well. If you don't fancy doing magic, you don't fancy doing any of the other ones, you can do any of the old ones. So the previous ones, and I'll maybe show you a video at some stage, maybe later. If you haven't already seen it, how many people have seen the physics engines ones from 2 years ago? The video, the YouTube video? Okay, if you haven't seen it, I'll share it so you can have a look at it. You can see what people previously did. They're also acceptable if you want to do something like that. Last year's assignment didn't really work out very well. There were no remarkable assignments submitted in the first semester, so I never bothered making a video of it. But one of the really cool things that happened in the world last year was that we sent a robot to Mars called Curiosity, and I found that really exciting. And I even got Paul Doyle to come in and give a class explaining how the Curiosity works and how it got there and everything. It was really exciting, but the assignments were terrible. So, but if you want to do a model of the Curiosity, that's cool as well. And you want to model some bit of Mars, really nice. Control a robot using skeletal tracking. So I've done this at a GameCraft earlier on this year. But you know, the Kinect is really easy to program, and you can do something like Pacific Rim. Has everyone seen that movie?
Yeah.
Okay, so in other words, you're moving around, and then the robot moves around and follows your movements. If you want to do that as well, make a game. If you want to make an actual game, I reckon it's probably more of a final year project than an assignment. But if you do a GameCraft, which is like, there's one coming up in November, we're actually hosting one. It'll be a 24-hour one. That's your assignment. Just do it. Okay? And then there's a couple of YouTube videos there and stuff as well. For final year projects, you can take the technology that you've learned on this course and you can do a really awesome final year project. And I've just identified a couple of the really cool ones that people have done in previous years. And I have some demos and stuff that I can show you, but maybe we should take a break or have a chat or something in a minute. How are we doing for time? Cool. Yeah, so this was Imagine Note. I'm sure you've heard about this, haven't you?
Yeah.
Alright, so this is all about teaching children, particularly special needs children. I can take my hat off now. Particularly special needs children, how to be more creative with music. So it's beautiful pictures, colours, sounds, motion tracking using a technology called the Sound Beam, Pre-Connect. So if somebody wants to do that, this is the kind of stuff you can do. You know, you can really change people's lives for the better. It was a privilege for me. It's definitely one of the highlights of my 12 or so years teaching in DIT to be part of this project and to just actually see people interacting with a piece of software which a student of mine made, and just to see, like, you know, with severe and profound autism, children that don't understand cause and effect, and then they use this thing and they suddenly discover, hey, I do this thing, this picture appears, and then it's just very transformative. So you can take the technology you're learning on this course and do those kind of things. This was, I'll just show you the previous one, Tai Chi Panda. So what Mark is actually seeing there is Tai Chi Panda. Tai Chi Panda is motion captured me doing Tai Chi, mapped into a model of a panda. And Mark sees the panda doing Tai Chi, you're able to interact with it with speech. And so all this technology is possible, right? It's very magical sort of technology. You should probably think about, you know, magical things. And that's the people at Imagine Note. I can show you another one. This was a great project from 2 years ago when the Kinect sort of SDK came out. First of all, this particular guy was interested in making orthoses. So these are actually supports for the foot. But when we did a bit of research, we discovered all kinds of interesting things. Like orthoses are also used for children with spina bifida, for curvature of the spine. And what happens is they take a mold, a plaster Paris mold of the shape of the spine. They make a plastic support which goes around and supports the child's back as it's growing up, right? And it's a very traumatic process because they have to put the plaster Paris mold on and they cut it off with a knife or scissors. That's quite a traumatic thing for a young child to have to go through that experience. So what we were looking to do was to scan the body using the Kinect, do some modeling in software, send the thing to a 3D printer and print the 3D, print it, you know? So anyway, all of these are possible using the technologies you're learning on the course. And these are just kind of final year project things rather than assignments because they're big projects. But I also sent around a list of Rift projects, you know? And then this is just the team competing. These were actually a team of second year students from last year, GT211 students. And they made this thing, they worked with a music teacher to develop this software. It runs on everything, even though it's using XNA and monogame technology. It runs on the iPad, runs on the iPhone and stuff, and it's actually for use on an electronic whiteboard. So you take an output from, for example, the iPad, connects up to an electronic whiteboard. You can do this kind of thing, these sort of gestures to move around the pitches, and also you can insert notes and stuff. So again, this is using gaming technology. This is XNA, all right? But it's actually a non-gaming application. So there are lots of non-gaming applications for the technology that you're learning on the course. And then that was Camille, who developed a thing called Chess to Go. Really cool combination of chess and Sudoku, and then Gamesplat. And that's what a games jam looks like, even though I have loads of other pictures. That's me and Phil Burke, my hero. And then You probably are already sick of hearing me talking about Blake Justice Project Hero. How many people have an Apple device, an iPad or an iPhone? Anyone got an iPhone in the class? Oh, fair enough, okay. If you have, go and download Blake Justice Project Hero. It's free, and they need every download that they can get. So these are graduates from this course who went on to do their own studio, and they've just released their first game. And also, very finally, keep in mind, nobody in the history of programming ever learned to program in a lecture, listening to the lecture talk. Alright? That's a fact. I'm sorry. I can't actually teach you anything unless you decided something you want to do and decided that it's something you want to learn yourselves, and whatever learning you do in this course you'll do because you want to do it, not because I told you to do it. Particularly at this stage of your careers. You're all old enough now. In fact, you know you're all old men and women wearing Oculus Rifts. Anyway, I've already done that. Anyway, so, you know, you got to bring a laptop to the class. You got to get everything that you need to code the stuff that we're going to make on the course running on your laptop, and bring your laptop to the class every week. We have a 2-hour lecture on Fridays, but really bring your laptops and bring pen and paper so you can draw pictures and stuff, you know. Yeah, consider how a plumber learns to plumb. Does a plumber sit in a big lecture theatre listening to somebody talk about the theory of plumbing? No, this is how a plumber learns to plumb. This is how a person learns to play a musical instrument. So you learn in a big room with lots of pianos or a big room with lots of guitars. You don't learn listening to somebody talking about the theory of playing the guitar. So you're never going to learn programming by sitting in a lecture, or games programming by sitting in a lecture as well. It's something you got to decide you want to do and do it. And the same for chefing, you know. There's no theory of being a chef. There's just making food. And the same with programming. There's no theory of programming. There's only programming. And actually, there's no such thing as learning programming as well. Did you realize that? You can't learn it. You just program. That's all. There's no learning program. You just program. Every time you program, you learn. You know, I learned so much over the summer by writing the thing that I wrote. And that's how I learned games programming, by writing a game engine. And that's how you guys will learn it as well, by writing stuff and by coding stuff. You know? That's it. Does anybody want to ask me any questions? Yeah.
Yeah, have you decided what the CA and exam, what the split will be?
It's
for
50-50.
50 grand. And is that 50% for the assignment, or will there be any corrected, like lab things?
50% for the assignment, but there could be a couple of deliverables on the assignment, and there is a breakdown of the marks. I can't remember it exactly, but it's similar to the breakdown of marks for your final year project. It's quite discretionary. So, in other words, it's stuff like technical complexity, visuals, in other words, how it looks or sounds or whatever. It's those type of things, project management. It's those types of things that are assessed, as opposed to, if you do these 5 things, you get these marks. Do you follow what I mean?
Yeah.
The consequence of that is it's quite discretionary. Alright, so, you know, I have to decide and I have to make a judgment as to, you know, how complicated the thing is that you've made. And the same as a final year project. But I've been doing it for years, so I'm pretty fair. And I'm open to discussions and that, you know, so that's the way it has to work. And also, we have to stop thinking of each other in terms of lecturer, student. You know, I want to learn from you guys, whoever is going to take this course. I did mention those special quests, right? If you want to take one of those special quests, then in order to get your first, and they're guaranteed firsts, right, in your CA, which means you get a minimum of 70 marks if you take one of those quests and achieve it. But in order to actually achieve your minimum of 70 marks, you must fork BGE, and you can look up how to do this, and you must do a pull request, and your pull request must be accepted. In other words, your code has to be up to the standard of everything that I've written, which, by the way, isn't very high. I'm not the best programmer in the world. But you must contribute your code back to the repository for next year's students, and then you get a guaranteed first. Is that okay? So that's what I'm saying. I want you guys to contribute to the course, and to take ownership of the course, and to feel like it's something that, you know, you're making this course. In fact, you know, I had this crazy idea that I wouldn't do PowerPoint slides. I'd get you guys to do the PowerPoint slides. What do you think? We'll see. We'll see. I don't think so. I want to provide you with some backup in case you miss a lecture. And I'm going to try and make an effort to video as many of the classes as well this year. So anyone else want to ask any questions? Come on, you must have questions.
Can we look back on the lecture notes? Will they be on your website?
Yeah, they're on my DIT website as opposed to web courses. You can look at, there's a full set of lecture notes from a previous course.
And last question, the support for the BG, support for Wii and Leaf.
Yeah.
What about the PlayStation Move? Do you already have that?
No, you can do it.
So that's one, alright.
That'd be great. Have you played a game called Johann Sebastian Joust?
No, I've seen it.
It's fantastic.
Yeah, that's
Great crack. Yeah. So if you make something like that with BGE again, guaranteed first. In fact, I would expand that. You know, if you make a reasonable contribution to any open source project this year, guaranteed 70%. You know, okay? Does that sound fair? Will we set up the leap, the Rift and have a go? I'll show you what I made. Did you see it? And I'll show you the game we made over the weekend as well. Actually, you can knock off the video for now because I've got.